Okay, friends, so in this quiz, we're building on the stuff from last week's quiz where we actually just kind of we shot from the hip, right? Is there a difference whether we reshuffle an entire deck of cards each time, or if we keep just dealing off the cards that are left in the deck after the previous experiment? I mean, obviously there's a percentage difference, and if you remember, this was if it took 5 cards until we saw all the suits. That was one of the larger percentages, 5 cards. Okay, so the fresh deck stabilized-ish around 15.29%, and the recycled deck-ish around 16.45%. So that number's bigger than that one. But the problem is, since this is only a sample, we can't say that in the entire population of all cards that are dealt, it's going to be exactly 16.45. That's probably close to what it is, but it's not exactly what it is. So that's why you need these margins of error. You always need a margin when you don't measure, check, ask, weigh, everything. And we didn't. We only did it. First of all, we looked at a simulation. And secondly, even if we had real cards, we couldn't check them all. So, to answer part A, what is the actual range of values between the confidence interval for the fresh deck? We've got to take the 15.21 and subtract it and add it to the 15.29. So for part A, we're going to have 15.29 minus, actually I want to do it this way because I can't do this math in my head, minus 2.81, so that's 8, 4, carry the 1, 12.48. And it's 15.29 plus 2.81, carry the 1, 11, carry the 1, 18.1. So my confidence interval in part A is 12.48, about 12 and a half, up to about 18.1. That's my confidence interval for part A. For part B, do the exact same thing, but you use the 16.45 minus 1.21. So, these should be percentages too. Sorry about that. My bad. So 4 to 15.24%, or might be as high as 17.66%. So there's the confidence interval for recycled decks. So now the point that we're trying to make here is, since we don't know the exact percentage of how many cards it's going to take, we have to estimate it using samples. We estimate it using samples that it's going to take 5 cards this percent of the time. But to be truly statistically optimally correct, you can't say just these numbers. You have to say between these numbers. Yeah, those numbers are in the middle of these numbers, but these numbers by themselves are too precise. Okay. Part C, do the intervals overlap, yes or no? One thing I've noticed is it's a little bit tricky to see whether or not these intervals overlap without actually looking at them more visually. Okay, so what I'm going to do right now is I'm going to hit pause on the recording, and I'm going to clear the board up a little bit, make us some room, and give you a nice drawing to represent this. Okay, I think we're set up now for it. I've put the fresh deck, I've color-coded it blue. So what I'm going to do down here is I'm actually going to draw this interval, but as kind of a horizontal line. So if I start at 12.48, I've given you a number line down here that goes from 12% to 18%. 12.48 is going to be kind of in the middle of 12 and 13. And 18.1 is going to be just beyond the 18. So if I connect those, that's weird. Chalkboard's acting up a little bit on me. Come on, chalk. There we go. That's the range of all those percentages in that interval up there. And if you think back to the lessons on statistics, the parameter, the true percentage in the population, is likely somewhere between those two ends. Well, I think the analogy I used was an aquarium, a fish in an aquarium. Think of a fish swimming back and forth. That's just about as certain as you can be where that parameter is. You don't know exactly, but you know it's probably between the two sides of the tank. Let's do the same thing for the recycled deck. 15.24 is going to be about here, and 17.66 is going to be out here somewhere. All right. Much narrower tank. Well, we mentioned why it's a much narrower tank, because there's a lot more trials with the recycled deck. Same logic though. We don't know exactly where the parameter fish is in that tank. It's kind of going back and forth. So you can see now, these intervals overlap each other. They share numbers. For example, they both have the number 16% in them. They both have the number 17%. They both have the number 16.5% in them. Okay, so that's C. D is the most important question, which is, based on this, is there a meaningful difference in using a fresh deck or using a recycled deck? Statistically, the answer is no, there is not. And the reason has to do with the fish. If the intervals overlap like this, it's impossible to know with certainty where the fish is in each tank. Remember, each tank has a fish. I keep using the word fish. It means the parameter, the true percentage in the population that it takes 5 cards to get all the suits. So for example, this fish might be down here, and this fish might be up here. In which case, this one is larger than that one because it's further to the right. But the trick is, we don't know exactly where this fish is. This fish might be exactly in the same place that that fish is, which would mean that the percentages were equal. Heck, this fish might even be down here, in which case this parameter is greater than that parameter. So since the intervals overlap, we can't tell with any kind of statistical certainty. So we have to say, you know what, the students that were doing the recycled deck thing, this doesn't show that they're different. Which means if they're not different, well then heck, if that's easier, do that. So then the question is, okay, Sean, wise guy, I'm going beyond the quiz now a little bit. If this means there's no difference, what would it look like if there were a difference? And I gave you a little bit of an answer to this right above answer choice C. Well, you'd have to have intervals that looked more like this. That way, no matter where the fish is in the blue tank, it's always going to be lower than the fish in the pink tank, regardless of how low it is in the pink tank. But that's not what happened here, remember. That's not what happened here. Here, the tanks overlapped, which means it's impossible to tell which parameter is further up the number line than the other. And that's a nice little primer for Math 244. Those of you headed down the path of statistics, that's a really kind of a cool way of seeing the implications of what sampling can do when you're studying a population. But let's not say any more than that. I'll let your stat teacher teach you all that good stuff. But this is a good start. We'll see ya.